This is R.D. Sharma Solution Class 12, Chapter 19, Exercises 19.19, Indefinite Integrals. 2x minus 3 divided by x square plus 6x plus 13. Now we have already done 3 questions, so you have a better idea how to do this. We will represent this 2x minus 3 in terms of this x square plus 6x plus 13. That is, we will multiply this by a and then d by dx of this one x square plus 6x plus 13. So this we are going to use again x square plus 6x plus 13 in differentiation. So what will be the differentiation of it? 2x plus 6 plus again a constant b. 2x minus 3 equal to this. So we will equate the similar terms, that is with x and with constant. So 2ax plus 6a plus b. 2x minus 3 is on the left hand side. 2x will be equated to 2ax. So from this x cancels, 2 cancels, a will be equal to 1. This will be kept in the second equation, which is 6a plus b, which if you equate on the left, it will be negative 3. A is 1, so 6 plus b equals negative 3. So b will be equal to negative 3 minus 6. It will be negative 9. So a and b value we got. So we'll put this in the equation number 1. So it will be 2x plus 6 and a is 1, so I am not writing it. B is negative 9. Now we have the denominator, so rather than writing this as one denominator, I am separating this for these two terms. So x square plus 6x plus 13 is now in the denominator of 2x plus 6, which was the first term, and negative 9. Now we are integrating it with respect to dx. So we have changed the original integration in terms of two other terms which are easily integrable. This one I1, this is I2. I1 will be this 2x plus 6 divided by x square plus 6x plus 13, and x square plus 6x plus 13 differentiation is only 2x plus 6. So we'll take this t equals to x square plus 6x plus 13. We'll differentiate it. So it will be dt by dx equals to 2x plus 6. And dt will be equal to 2x plus 6 into dx, which is the numerator actually for I1 term. This 2x plus 6 dx, this will be dt integration. What will be the denominator? It will be t. So dt by t, this will be log modulus of t plus constant of integration. So let me write the final answer now. Log modulus, replace t by x square plus 6x plus 13 and plus constant of integration. This is the first integration, I1. Let us call the constant of integration as C1. In I2, we have the denominator, numerator can be taken out. So it is simply dx by x square plus 6x plus 13. So we'll try to make this x square plus 6x plus 13 or this quadratic equation as a perfect square. So take 6, which is the coefficient of x, divided by 2, it will be 3, square it, add it, subtract it. That is, if you have x square plus 6x plus 13, then you have to add and subtract this 3 square. Just add and subtract. So you got x square plus y square, x square plus y square plus 2xy, that is x plus 3 whole square. Now 13 minus 3 square, 13 minus 9, which is 4, which is 2 square. So x plus 3 whole square plus 2 square. So if you want to write the integration, 9 will deal later, dx by x plus 3 whole square plus 2 square. So let me write the formula which we are going to use. Dx by x square plus a square integration will be 1 by a tan inverse x by a. This is the formula which we are going to employ here. What is this? 1 by a. 1 by a. 1 by a. A is what? 2. A is 2 and x is x plus 3 here. So 1 by 2. Now 9 was also there, so let us introduce 9 here as well. Tan inverse x by a, x plus 3 by 2. And this will be with a constant of integration C2. Finally, we'll add this I1 and I2. So this I1 plus I2 will be I. So just add it. See, I've written negative because it's actually I1 minus I2. There is a negative sign in between. So I1 is log modulus x square plus 6x plus 13. And the second term is negative 9 by 2 because it is negative in between I1 and I2. Tan inverse x plus 3 by 2. Now this constant of integration C1 and C2 will be added and we will call it as a constant of integration capital C. So just write capital C here. This is your final answer. So this is the way we are going to do it. So all other questions which are coming, they are almost of the same nature. Now this question, as you already know how to do this, we have done already 3-4 questions. So the same thing and same formula will apply. There is no special trick which is to be applied here. Now this is 2x by 2 plus x minus x square. This is also almost similar to what we have done. But since it looks like a different question, in a way, we'll try to solve it. We need to get this numerator 2x in terms of differentiation of the denominator. For that, we'll use two constant also, a d by dx of 2 plus x minus x square plus capital B. A and B are constant. Differentiation of 2 plus x minus x square is what we want to represent. It's 1 minus 2x when you differentiate it. So 2x will be equal to a. What is the differentiation I just told you? 1 minus 2x plus b. Now we'll multiply everything on the right hand side and equate it with the left hand side of the similar terms. So a minus 2ax plus b. A plus b minus 2ax you can call. And we will be equating the similar terms. So 2x will be equated with negative 2ax. So negative 2ax it is. This is the first equation. And a plus b equals to 0 because there is no constant term on the left hand side. So a plus b will be equal to 0. From here this 2x gets cancelled. Negative a equals to 1. A is negative 1 here. This a, when you put it here, negative 1 plus b equals to 0. B becomes 1. So the equation has become something like this. A and b we have got. That is, we have just represented 2x in some other term. We have not changed it. We just wanted just that some final integrability we may achieve. So negative 1 I am writing in place of a, 1 minus 2x. Now the denominator, which is 2 plus x minus x square, can be taken separately with these two terms. Because negative 1 into 1 minus 2x plus 1 is essentially 2x only. So 2x divided by 2 plus x minus x square, I am separating this 2 plus x minus x square. So let's take it. Now when we integrate this is the actual integration. This we are calling it as I1. This we are calling it as I2. So we'll integrate this first term, I1. So I1 will be equal to, we'll take t equals to 2 plus x minus x square. Dt will be what? It will be 1 minus 2x into dx, which we have already differentiated initially. So dt will be equal to 1 minus 2x into dx. So this one I1 if you take t as denominator, 1 minus 2x will be numerator. There is a negative also. Denominator was taken as t. Numerator already became dt. And negative we have taken outside. So it's simply log modulus of t plus constant of integration and followed by or preceded by a negative sign. So now change this t to 2 plus x minus x square and then plus constant of integration. We are calling it as c1. How about I2? I2 is 1 by 2 plus x minus x square. So we would like to make this 2 plus x minus x square as a perfect square. First write negative x square, then plus x plus 2. We are writing in decreasing power of x. But we have to make this as a perfect square. For that we need a positive x square. So just take negative out of it. When you take negative out of it, it will be negative outside, but x square minus x minus 2 will come inside. X square minus x minus 2. Now we have to make this as a perfect square. What is the coefficient of x? Which is 1. Now divide it by 2. Square it. And add and subtract. So x square minus x minus 2. I requested 1 by 2 to be added and subtracted in form of square. So a square plus b square plus minus 2ab. So x minus half whole square it is. A square plus b square minus 2ab. Now minus 2 and minus half whole square. It will be minus 2 minus half 1 by 4. If you take a negative sign outside, it will be 2 plus 1 by 4, that is 4 to side 8, 9 by 4 it will be. 9 by 4, now this is very good. 3 square by 2 square you can write. So the whole thing will be like this. 3 by 2 whole square now. So this I2 will be integration of dx divided by x minus half whole square. And there is a negative also. We have already taken a negative. X minus half whole square minus 3 by 2 whole square. So x square minus a square in terms in the denominator, what is the integration value? 1 by 2a log x minus a by x plus a inside the modulus sign. So 2 by a, 2 into 3 by 2. Now plus c2, just write it as c2. 2 gets cancelled, 1 by 3. Now we'll do it in this way, 1 by 2, negative 1 by 2, negative 3 by 2, that is 1 by 2 plus 3 by 2. You can take negative outside, so 4 by 2, 2. 3 by 2 minus 1 by 2 is 2 by 2, which is 1. So the numerator will come as log x minus 2 and denominator will be x plus 1 inside the modular sign. But there is a negative sign outside, okay? Just remember, you can just invert this x plus 1 and x minus 2 if you want to take this negative which is outside I2 inside. So I'm writing the final answer now. This is a negative, so negative log 2 plus x minus x square. Constant of integration we are going to add just now. So this is 1 by 3. So you can make this negative plus because there is already a negative in between. Or you can take negative and invert this x minus 2 and x plus 1. That is, you can reverse it also. Because see, negative log x with a negative sign in front is simply log 1 by x. X minus 2 by x plus 1. I am writing this like this. But let me reiterate that you've changed the sign. You just reverse this numerator to denominator, denominator to numerator. That is what is the best way. But you can keep it like that also. Just to make it equated to the r.d.sharma solution, I'm just showing it to you. So this will be done. I hope you'll be able to do this. Okay. Okay, let's go ahead now. 1 minus 3x by 3x square plus 4x plus 2. Now this is very easy for you if you have understood the previous questions. So I'm just showing you the reference. You can just try it by yourself. Same thing here, 2x plus 5 divided by x square minus x minus 2. This can also be done easily. There is no special thing. Just represent x square minus x minus 2 as 2x plus 5 with a differentiation of x square minus x minus 2. Formula also remains the same. Now this question is somewhat different from what we have done earlier. So how are we going to do it? We will separate these terms. We'll separate this term and then we'll try to devise some formula, and then that formula, an integration can be done. So we have ax cube by x raised 4 plus c square. This is the first integration I'm talking about. So I'm separating this ax cube terms and bx term. So you have bx and denominator is x to the power 4 plus c square. Now I know that x to the power 4 differentiation will be x cube. But in order to get x here, I will take x square whole square because differentiation of x square can give us x. So x square plus c square, x square whole square plus c square in the second term. But first term will keep it as x to the power 4, will not change it. So this I1 will be something like this. I'm taking this x to the power 4 as t. So dt by dx will be equal to 4x cube. That means dt by 4 is x cube dx because we have x cube in the numerator. That's why we wanted it. So this x cube dx can be replaced as dt by 4. So dt 4 I'm taking it outside. A is already there, so a by 4. Now x to the power 4 plus c square. So it is t plus c square. T plus c square. A by 4. See, c square is just a constant. You can call it as t plus 1, t plus a like this. So you can just use the formula of log dt by t because t plus 1 will be t plus 1 only. So log t plus c square. Now I'm replacing t by what we have taken x to the power 4 plus c square plus constant of integration which is c1. This is your I1. How about I2? See, x square we have taken as t. We are taking it as t. X raised 4 was written as x square whole square, x square as t. So dt by dx will be equal to 2x. dt will be equal to 2x dx. dt by 2 will be x dx. So in place of x dx, write dt by 2. So integration of dt, I'm taking a half outside, b was already there, so b by 2. Now x square was taken as t, so this will be t square, and plus c square has come. So you can call it as dx by x square plus a square formula. And you already know the formula of this, 1 by a tan inverse x by a. X can be taken as t and a can be taken as c here. Again, let me tell you, integration of dx by x square plus a square is 1 by a tan inverse x by a. So I'm writing b by 2 here and using the formula 1 by a. What is 1 by a? Let me write it also, x square plus a square. So 1 by a tan inverse x by a. Just to recall that you have this formula stamped into your mind. We'll take x as t and a as c. So 1 by a, which is 1 by c, tan inverse x by a, which is t by c. T by c here. Plus constant of integration, which is your c2. I'm adding a c2 now. So b by 2c tan inverse, what was t? T was taken as x square, so x square by c. Plus some constant of integration, call it as c2. Now we have to add these two terms, I1 and I2, in order to get an I. So I'm adding it here only. You know already I1 we have got, I2 we have got. So I'm just cancelling this C1 just to show you that these two terms can be added, and this is the final addition which you will get. So b by 2c tan inverse x square by c has been added to I1 now, and c1 and c2 combined called as capital C. So that's your final result. Okay. Now let me give you a simple reference or hint so that you can just follow this. There can be a different way in solving it, but you know that I solve differently. There are certain solutions or reference I show you which may be different. but the result remains the same always. This question we will take in the next discussion. Till then, thank you so much and have a good one.